Today we will study about Fourier theorem and Fourier series. Complex periodic function, if we denote it by fx, can be expressed as sum of sine or cosine waves. Fx equals to a naught plus a1 cos x plus a2 cos 2x plus so on up to an cos nx plus b1 sin x plus b2 sin 2x plus so on up to bn sin nx and plus so on up to. Here a naught, a1, a2 and b1, b2 and bn are Fourier coefficient. अगर हम फंक्शन को रिप्रेजेंट करना चाहें एफ एक्स इक्वल्स टू ए नोट प्लस समीशन एन इक्वल्स टू 1 to infinity ए एन कोस एन एक्स प्लस बी एन साइन एन एक्स. अब लिमिटेशन क्या होंगी फोरियर थ्योरम की? फर्स्ट लिमिटेशन है जो एफ एक्स है फंक्शन शुड बी सिंगल वैल्यूड, एक वैल्यू होनी चाहिए. जहाँ पे इसकी वैल्यू एक से ज़्यादा होगी वो अपनी फोरियर सीरीज़ को हम वहाँ शो नहीं कर सकते. सो fx, if we denote fx along y-axis and x along x-axis, then at this point कितनी वैल्यूज़ हैं? 1 2 3 वैल्यूज़ हैं. यहाँ पे एक वैल्यू है, ऐसे यहाँ पे कितनी हमारे पास 3 वैल्यूज़ हैं. सेकेंड fx मस्ट हैव फाइनाइट वैल्यू होनी चाहिए. ये y-axis के along हमने डिनोट किया fx. यहाँ अगर हम वैल्यूज़ देखते हैं फाइनाइट वैल्यू होनी चाहिए, इनफाइनाइट वैल्यूज़ नहीं होनी चाहिए फंक्शन की. थर्ड एफ एक्स शुड हैव फाइनाइट नंबर ऑफ डिसकंटिन्यूज, जो डिसकंटिन्यूटीज़ हैं वो भी फाइनाइट होनी चाहिए. फाइनाइट नंबर ऑफ मैक्सिमा या मिनिमा होना चाहिए जो इसका पीरियड है टी, उसमें फाइनाइट नंबर ऑफ मैक्सिमा एंड मिनिमा इन द पीरियड ऑफ टी. ए फंक्शन एफ एक्स said to have a discontinuity at x equals to x naught if the right-handed limit of x at x equals to x naught and the left-handed limit of fx at x equal to x naught are not equal. Means right-handed limit and left-handed limit are not equal. Fx in this case f x naught minus is not equal to f x naught plus. Such discontinuity is shown in this. For function fx at x equals to x naught, a function of this type is called piecewise regular function. It is called piecewise regular function. Now evaluation of Fourier coefficient. Evaluation functions sin x and cos x are periodic with period 2 pi. Same is true for sin nx and cos nx for all integral values of n, because sin nx plus 2 pi equals to sin nx and cos nx plus 2 pi equals to cos nx. Therefore, the function fx represented by finite series is also periodic and has period of 2 pi. The values of Fourier coefficients of function fx can be determined for the interval minus pi as described. This value for other periods will be determined. For evaluation of Fourier coefficients, we can make use of orthogonality property of sine and cosine functions. First, integration minus pi to pi sin mx cos nx dx equals to 0 for all integral values of m and n. Now we will do its proof. Integration minus pi to pi sin mx cos nx dx equals to 1 by 2 integration minus pi to pi sin m plus nx plus sin m minus nx to dx minus 1 by 2. If we solve the integration, cos m plus nx divided by m plus n plus cos m minus divided by m minus nx, इंटीग्रेशन चला जाएगा लास्ट में माइनस पाई टू पाई माइनस 1 by 2 1 over m plus n cos m plus n pi minus cos m plus n into, if we put the value of limit from minus pi to pi, upper limit minus lower limit plus 1 by m minus n cos lower limit upper limit cos m minus n pi plus cos m minus n into minus pi equals to 0 for all integral values of m and n. Now we will do second integration from minus pi to pi sin mx sin nx dx equals to pi del mn for m not equal to 0. Del mn is Kronecker delta, which is unity if m equals to n and 0 otherwise, n equals to 0 otherwise. Integration from minus pi to pi for m is not equal to n sin mx sin nx dx equals to 1 by 2 integration from minus pi to pi cos m minus n into x minus cos m plus n into x dx 1 by 2 sin m minus n x by m minus n minus sin m plus n by m plus n into x. Integration limits goes to last minus pi to pi equals to 0 because sin m minus n into pi equals to sin m minus n into minus pi equals to 0, and in the same way sin m plus n into pi equals to sin m plus n into minus pi equals to 0. This becomes 0 and this also becomes to 0, so the whole value will convert into 0. This we have done for m is not equal to 0. Now if we have the value m equals to n not equals to 0, integration from minus pi to pi sin mx sin x dx equals to integration minus pi to pi sin square mx dx equals to 1 by 2 integration minus pi to pi 1 minus cos 2 mx into dx 1 by 2 x minus sin 2 mx by 2m integration minus limit goes to the last one minus pi to pi 1 by 2. If you put the limit upper limit minus lower limit pi plus pi minus 0 1 by 2 into 2 pi 2 से 2 कैंसिल हो जाएगा equals to pi sin 2m pi equals to 0. In the similar way sin 2m minus pi equal to 0. Integration from minus pi to pi sin mx sin nx dx equals to pi del mn for m is not equal to 0. Now for integration minus pi to pi cos mx cos nx dx equals to pi del mn for m is not equals to 0. It's proof for m is not equal to 0. Integration from minus pi to pi cos mx cos nx dx equals to 1 by 2 minus pi to pi integration cos m minus n x plus cos m plus n out x into dx. इंटीग्रेशन खोलने के बाद 1 by 2 sin m minus n x by m minus n plus sin m plus n x by m plus n. इंटीग्रेशन लास्ट में चला जाएगा लिमिट minus pi to pi equals to 0. Now for m is equal to n but not equal to 0. Integration from minus pi to pi cos mx cos nx dx integration minus pi to pi cos square mx dx equals to 1 by 2 integration from minus pi to pi 1 plus cos 2 mx dx equals to 1 by 2 x plus sin 2 mx by 2m. लिमिट्स पीछे चले जाएंगी minus pi to pi is equal to pi. Integration minus pi to pi cos mx cos nx dx equals to pi del mn for m is not equal to 0. Now we will find the value of a naught, an and bn. To find the value a, to determine a naught, to find a naught or to determine a naught, integration minus pi to pi fx dx equals to a naught integration minus pi to pi into dx equals to a naught into 2 pi. Other integrals will vanish. So equals to a naught into 2 pi. A naught equals to 1 by 2 pi integration minus pi to pi fx dx. Now we will evaluate an to determine the value of an. Minus pi to pi fx cos nx dx equals to minus pi to pi an cos nx into dx. All other integration will vanish by using the orthogonality property. Minus pi to pi fx cos nx dx equals to an pi. An equals to 1 by pi integration minus pi to pi fx cos nx dx. To find value of bn, multiply the last equation with sin nx and integrating x in interval minus pi to pi. Fx sin nx dx equals to minus pi to pi bn sin nx dx. All other integral will vanish, and using the orthogonality property, integration minus pi to pi fx sin nx dx equals to bn pi. By using orthogonality property, bn equals to 1 by pi integration minus pi to pi fx sin nx dx. By using these equations 1, 2 and 3. We have find out the value of a naught, an and bn. The Fourier coefficients can be determined. Now we will evaluate cosine series for even function. When fx is an even function of x, fx is even function of x, then f of minus x equals to f of x. Then it is possible to express fx as an even function, fx as a cosine series, because coefficients of bn of all the sine terms will become 0. Bn of coefficient of all the sine terms will be 0. Fx, as fx is an even function, integration from minus pi to pi fx dx equals to 0 to pi fx dx. A naught equals to 1 by 2 pi integration from minus pi to pi fx dx equals to 2 by 2 pi integration minus pi to pi fx dx. 2 will be cancelled out. We have the value a naught equals to 1 by pi from 0 to pi fx dx. यहाँ पे ट्वाइस इसलिए किया है कि ये जो लिमिट है फ्रॉम माइनस पाई टू पाई, इसको हम कन्वर्ट कर देंगे 0 टू पाई में, तो 2 बाई 2 पाई हो जाएगा. ए नॉट इक्वल्स टू 1 बाई पाई इंटीग्रेशन 0 टू पाई एफ एक्स डी एक्स. कोसाइन फंक्शन is always an even function. As fx is an even function, therefore product of fx and cos nx is also an even function. So cosine function is also always an even function. Now integration from minus pi to pi fx cos nx dx equals to twice 0 to pi fx cos nx dx. An equals to 1 by pi integration from minus pi to pi fx cos nx dx. An equals to 2 by pi integration from 0 to pi fx cos nx dx. The function fx sin nx is an odd function because fx is even function and sin nx is an odd function. Property of an odd function: minus pi to pi fx sin nx dx equals to 0. Bn equals to 1 by pi integration minus pi to pi fx sin nx dx. Bn will be equal to 0. Thus all the coefficient of sine terms are 0 and only cosine terms will be present in the Fourier series of an even function fx. Means fx equals to a naught plus summation n equals to 1 to infinity an cos nx. Now sine series for odd functions. When function fx is odd function, means f of minus x equals to minus fx, coefficients of a0 and an will become 0 and only sine terms will exist in the Fourier series. Such a series is called sine series. As function fx is odd function, minus infinity minus pi to pi fx cos, so fx dx equals to 0, a0 equals to 1 by 2 pi integration from minus pi to pi fx dx, a0 equals to 0. Function fx cos nx will be odd function because it is product of odd function fx and cos nx. Integration from minus pi to pi fx cos nx dx equals to 0. An equals to 1 by pi integration from minus pi to pi fx cos nx dx. An equals to 0. The function fx sin nx is even function and it is product of two odd function. Fx sin nx is even function and product of two odd function fx and sin nx. Integration from minus pi to pi sin nx dx equals to twice 0 to pi fx sin nx dx. Bn equals to 1 by pi integration minus pi to pi fx sin nx dx. Bn equals to 2 by pi integration from 0 to pi fx sin nx dx. The odd function fx will contain only sine terms in its Fourier series. Fx equals to summation n equals to 1 to infinity bn sin nx, where the coefficient bn are given in equation. In this equation, bn equals to 2 by pi integration 0 to pi fx sin nx dx. Now for Fourier series for the interval 0 to pi, when function fx is periodic function and satisfied Dirichlet conditions in interval 0 to pi, then fx can be expanded in the form Fourier series similar to that for interval minus pi to pi. Even for the interval 0 to 2 pi, fx can be written as fx equals to a0 plus summation n equals to 1 to infinity an cos nx plus bn sin nx. Fourier coefficients are given by a0 equals to 1 by 2 pi integration from 0 to 2 pi fx dx and an equals to 1 by pi 0 to 2 pi fx cos nx dx and bn equals to 1 by pi 0 to 2 pi fx sin nx dx. We find the value for the interval 0 to 2 pi. The values of a0 will be equal to 1 by 2 pi integration 0 to 2 pi fx dx and an equals to 1 by pi integration from 0 to 2 pi fx cos nx dx and bn equals to 1 by pi integration from 0 to 2 pi fx sin nx dx.